Hello everyone. In the previous set of videos, we discussed about using unsupervised learning for classifying Wikipedia articles. Today, we are going to leverage the large language models for the classification and prepare a dataset for supervised fine-tuning. Let's get started. Before we go ahead and do the actual implementation, I would like to explain what are the different steps that we have for classifying these Wikipedia articles. So we have the original article text. We are going to extract the article text and send it to the pre-processing step. In the pre-processing step, we are going to extract only the first paragraph from this article. The reason being, the Wikipedia articles on the first paragraph, it sets a very good context of what this article is about, and which is more than enough for a large language model to classify this article into one among those 20 categories. So once the pre-processing is done, we are going to send the pre-processed output to a prompt. So we are going to construct a prompt. The prompt will take two inputs. The one input is AX, which is nothing but the pre-processed article text, and it's going to take 20 different categories. So for instance, say sports, history, politics, entertainment, and so on. Okay, so we are going to feed in both our article and the list of categories that we want to classify in and construct a prompt. Basically, we are instructing our large language model to feed in, to take this article and the 20 categories and classify this particular article into one among these 20 categories. Once we have generated the prompt, we are going to send this prompt to the large language model. So here we have our LLM, and the output of large language model will be the actual category. So this will be our category name. For example, sports or history, or the category which the article AX belongs to. Let's see how we can implement this in Python. Let's go ahead and load the dataset using load dataset module from datasets. Make sure the datasets is installed in your system. If not, install it using pip command. Once the dataset is loaded, let's print. You can see we have ID, URL, title, and text. So let's print the sample dataset. Dataset of 0, dataset of train of 0. So we can see this is the first article. Since we are interested only on the text, let's extract only the text column. So I'm going to grab first 1000 articles and I'm going to take only the text column out of it and save it to another variable. Say these are our articles. Okay, so the length of articles will be 1000 and each article will have the actual article content. So this is our first article content. As I was mentioning before, this article is too long and we don't need all this information for classifying this article into one among these 20 categories. As we can see, the first paragraph very well states about what this article is about, and which will be more than enough for the LLM to classify this article. So we can quickly write a list comprehension. So for X in articles, for each article, I'm going to split this article based on that session. So I'm going to cut off all these paragraphs and just pick only the first paragraph. So I'm just going to reassign this to articles. Okay, now let's print articles of 1. You can see we have cut down most of this text, right? And we are preserving only the first paragraph. Okay, so this is a basic pre-processing step. Why this step is important? Because we are going to use API based large language models, and most of the API based large language models are charged based on the input tokens and output tokens. So the more the information that we send, we are going to get charged much. So for LLM to perform classification, we can do a basic set of pre-processing, what are the information that LLM needs to classify, and we can send in a very limited set of information so that we don't get charged much. Before we go ahead and do the actual implementation, we need to have clarity on two important items. One, we need to decide on which API based model we are going to use. And number two, after we decide using one particular model, we need to understand the cost implications of it. So there are multiple API based models available in the market. The one that we frequently use is OpenAI's ChatGPT. So for this example, we are going to use GPT 3.5 Turbo, and in the future videos we are going to discuss about open source models and other different models which can even run on your CPU. We have decided that we are going to use OpenAI's GPT 3.5 Turbo. So let's go ahead and see how much we are going to get charged if we want to classify these 1000 articles. Right. So let's print the first article text. So this is the first article's text, and let me copy this text and paste it in OpenAI's tokenizer. So as we can see, this article contains 99 tokens, right? So we have 1000 different articles like this. For each article, copying these articles content and pasting it in tokenizer is going to be really hard. So for doing that, we are going to use a library called tick token. Okay, so if the tick token is not available in your machine, you can install it using pip install -u tick token. So we are going to define an encoding which is tick token dot encoding for model, and the model that we are going to use is GPT 3.5 Turbo. Okay. So let's, okay, so if you do encoding.encode of a text, say for example, how are you, it's going to encode this particular sentence into tokens. Basically it gives you 3 different token IDs. So if I print length of this particular line, then I'm going to get the total number of tokens for this particular sentence. So I can very well do the same process for all our articles. So let's quickly from TQDM import TQDM. So for article, in articles, for each article, let's have a variable total tokens equals 0, and total tokens will be plus equals length of encoding.encode of the actual article text. So I'm iterating through each article and passing it to the encode function, finding the length and summing up all these token lengths. So let's go ahead and print the total tokens. So it's around 88,327 tokens. So this is just a rough estimate of how many tokens that we are going to send it to OpenAI. Of course, it's going to be more because we are going to write a prompt which has an instruction, but it's just a rough estimate. So we are going to send around 90,000 tokens to OpenAI. Let's see how much we are going to get charged for it. Let's open the OpenAI's pricing platform, and we are going to use GPT 3.5 Turbo. So here we have GPT 3.5 Turbo. So for using the default GPT 3.5 Turbo, we're going to get charged $0.5 per million tokens. So if you're going to send 1 million tokens as input, we are going to get charged of $0.5. So we are going to send around 88,327. So let's do total tokens star 0.50 $0.50, and let's divide it by 1 million. So we are going to get charged of around $0.04, around $0.044 for classifying these 1000 articles.